All right, in this lesson, we're looking at the graphs of polynomial functions. Polynomials include linear functions, quadratic, cubic functions, and then you just kind of continue on with the exponent, but they are all going to be x to a positive whole number terms. So all polynomial graphs have some things in common. First thing we're going to look at is just how to graph them using our little TI-84 calculator. We'll be using that a lot this year. Do a lot of different things, and so how do we graph? So first question, where do I put the equation? To put the equation, you're going to put it right here. That y equals button, that's what you're going to click if you're going to try to type in an equation. Hit the y equals button. Right? You'll see the equation's already on mine. Now, a problem actually is on mine as well. So if you see at the top, it says plot 1 is highlighted. You actually don't want that unless you're trying to do scatter plots. We'll get to that later. So unhighlight that, and we can just hit the clear button, clear all of that. So right here, y1, that's where I would type my equation. What button makes an x, right? There's a couple ways you can do this, but the easiest and probably best is this button right here. That button right there makes an x. If you click on that one, there's an x. Some other things we need to know is, how do you make an exponent? So it depends on what the exponent is. If the exponent is a 2, well, then you just click that button, and it's easy enough. So I click that button, boom, puts an exponent of 2 right there. Now, let's say I don't want an exponent of 2. Let's say I want an exponent of 3 or 4 or something like that. Well, there's not a special button for that, but I use this right here to do any specific exponent other than 2. So if I click that button, then it gives me a little box up there, and I can type whatever I want. Now, the problem with this is, let's say I type in a 4. Notice that my cursor is still up there. And if I start typing like plus 6x minus 2, all of that's going in the exponent, right? So come right here, delete, delete, delete. So after I type in my exponent of 4, I need to hit the right arrow before I continue typing the rest of my equation, whatever it is, all right? So let's say I have that. To see my graph, I hit the graph button. I did that kind of fast. We pull the little thing here. So this right here, that's the graph button. I hit that button. So there's the graph button. How do I see my graph? Well, the problem, it comes back to this question right here. How do I fix my window? So see, the last time I did this, I was looking at a scatter plot that was way up here in the first quadrant, and I can't see my graph. So to fix the window, clear on the drawing itself, we have a series of buttons. We're going to hit zoom, and then we're going to hit the number 6. Zoom, and then the number 6. Hit the zoom button, and then down there is zoom. Number 6 is Z standard. So if I come down here and click the number 6, it takes me back to my standard window. And now I see my graph. Now, if I want to zoom in, I can do that with a couple different ways. One, I can click the zoom button. I can go to zoom in, and I can hit enter. And I can just say, okay, I want to zoom in right down here, this part. And so I moved my little cursor to wherever I want to zoom in at, and move it so right there. And then if I hit enter, it'll zoom in at that spot. Now it's still set to zoom in. So if I move my cursor and click enter again, it's going to keep doing this over and over again as long as I click enter. Every time I click enter, it's going to keep zooming in. And I'm like, oh, wait, that was way too much. So I can zoom out, or if I can remember, if you ever get stuck, zoom 6 resets your window. Another thing you can do is say, I just want to look at, let's come right here. Let's say I just want to look at this particular box right there. I want to see that. Well, I see that my minimum, my x values, that would be from -1 to 3. And my y values, 10, 8, 7, 6, probably 5, -5 to 2. Okay, so that's what I want. I want to be able just to see that particular box. I can look up a specific window. So if I want to look at just that specific window, I come over here to window and I say, okay, now I have to kind of remember what was the x? -1 to 3. So my window, my x minimum is going to be -1. My x max is going to be 3. My y man, I think it was like -5, and the y max, if I remember correctly, was like 2. Graph, clear out that, and there you go. It did just that window that I told it to look at. All right. So a couple of different ways you can fix your window. And again, most important thing is zoom 6, being able to go back to our standard window. Most of the time, we're not going to have to zoom in, but sometimes we will. All right. There we go. So that's how we graph. Oh, getting ahead of myself there. Let's go to our paper. Sketch the graph of each function. So we're going to use this one as our example. I already did a little bit, so let's see, how do I do this? So starting off, y equals. I have that little function there I use as my example, so I need to get rid of it by hitting the clear button, right? Clear, top right-hand corner, just underneath the arrows. So if I want to type that in, I hit the X button. I need an exponent other than 2, so I have to hit this little, hat or caret or whatever you want to call it. Type in the number 3, but I need to make sure I'm careful to hit the right arrow. Minus 2, and then x. Now, because the exponent's a 2, I can just use the little x squared button, and I don't have to hit the little right arrow. It automatically just does it. And then minus 2. Now, this doesn't affect this one as much, but it will affect when we get to like number 3. This button right here and this button right here are not the same, okay? This one is for subtraction. Okay, I was subtracting, so therefore I use that button. This button down here is for negatives. Okay, they are different. I use this one when it's like the beginning and I'm putting a negative in front of my first term. Okay, so that's negative, the other subtraction. All right, so I typed it in, so now I'm going to hit the graph button. My window's already set up pretty well. And so then just best I can, I'm going to try to put that on my graph. Okay, just draw it best you can. Now, to help you draw it, there's a couple things you can do to make it as precise as possible. You can hit the trace tool. Okay, when you hit the trace, and I'll circle that so you can see what I clicked on. So there's a trace button. It puts a little cursor there. Okay, at some point, well, there you go, 0, -2. I know to put a point over here, so let's come over here. 0, -2, so I'm going to put a little dot right here and say, okay, well, there's a point on my graph. Well, I can use this cursor and I can go left or right, and it gives me all these different coordinate points. But the problem is, of course, if I click, they're all decimals. They're not whole numbers. So I hit the trace button. I don't have to just use left and right. I can type in values. So for instance, I hit the trace button. I'm going to come down here and click the number 1. See, it says x equals 1 and hit enter. And then it tells me that coordinate point. It says x equals 1, y equals -3. And say, oh, okay, coordinate point, that would be right there. All right, well, let's try another one. What about 2? Enter. All right, if I plug 2 in, I get y equals -2. So I come in and say, okay, that's right about there. Well, 3. The 3, I get 7. That's pretty close to the top of my graph. That's up there. I see I'm definitely going to go off my graph if I keep going that direction. So let's go the other way. About -1. Okay, -1 is -5. -1 is -5. That's right about there. Sorry, my points aren't very good because I'm trying to do this with the mouse. And we'll try one more, but I think we're about to go off our graph. -2, negative 18 off my graph. Yep, but that's okay. That gives me enough coordinate points that I could then sketch the shape of my graph. And I definitely put -1 at -3, not -5. Sorry. Let's fix that. Yeah, so that point was -5, and -5 is located in between 4 and 6, which is right there. There we go. All right, so that's how we can graph on our calculator. All right, now number 3 illustrates a problem we were talking about earlier. So I hit y equals for number 3. If I hit clear, if I just use the subtraction button, minus x to the 4th, exponent 4. Oh, sorry, I'd already hit it. Exponent of 4 minus x to the 3rd plus 3x squared minus 4. Okay, there we go. This is going to be wrong. I hit graph and I get this message right here. Now, whenever you see this kind of message and it gives you quit and go to, don't hit quit, hit go to. So this is actually a really cool feature. If I go to and I hit enter, that little blinking cursor is blinking on the problem. And so it's telling me, hey, this right here, this is the problem. And the problem is I put a subtraction sign where I should have put a negative, right? So, and it's the one in front, that would be this one right here, is saying, you told me to do subtraction, but there's nothing to subtract. It's just a negative. So for that one, not this button, that's where I needed the negative. Okay, so I'm going to go and put a negative in its place, and notice the difference. You can see that the calculator makes the negative smaller than the minus. That way you can see the difference if you make a mistake. All right, and now I can hit graph and you'll give me the graph. So go ahead and try to sketch the graphs of numbers 3 and 4. You can do number 2 as well, but I already put that one up on the screen, so you hopefully saw that one already. Go ahead and do number 3 and 4. Pause the video and then I'll show the answer. All right. This is what you should have gotten for numbers 3 and 4. Now, go back. So we can see all this. And this will illustrate our next part, number of turns. So how many times does number 1 turn? To the graph on problem number 1, how many times does it turn? Let's think about this. So you're traveling this direction, you're going, and then when you get here, you turn. You were going up, now you're going down. That right there is a turn. And then you're going down, and then right there, you turn again. So it turned 2 times. Number 2, let's see, if you're going up this way, how many times do you turn? Well, you turn here, you turn here, there, and there. 4 turns. All right. Number 3, 1, 2, 3 turns. And for number 4, it's just 1 turn. So the question is, how can you figure out how many turns there are without looking at the graph? If all you have is that, you're not graphing it, can you figure out how to go from that to there? All right, I'll give you a second to think about it. Go ahead and pause the video, see if you can figure out a way to go from the equation or the function to the maximum number of turns. All right, so see whether what you came up with was correct, if you were able to come up with something. So maximum number of turns is we take the highest exponent, and we subtract 1. highest exponent minus 1 always gives us the maximum number of terms. Now, these four graphs all end up turning the maximum number of terms. Maximum number of terms, so I come over here. Okay, maximum number of terms is the maximum number of times a specific polynomial can turn. So for instance, all polynomials who have x to the 5th power can turn a max of 4 times. 5 minus 1 is 4. Max is 4 terms. Now, not everything that has a highest exponent of 5 turns 4 times. It could turn less than that. It can turn 3 times, 2 times, 1 time, or none at all. Okay, so maximum number of turns. At most, it's going to turn 4 times. So it will never turn more than 4. Real zeros. Real zeros have a few different names they go by. So real zeros can also be called real roots. They can be called x-intercepts. And occasionally we call them solutions in some specific cases. All right, so what they mean is, if I have an x-axis, I really don't even need a y-axis. Yeah. Real roots, zero solutions, whatever, are where it touches the x-axis. Make sure I drew one that was a little weird. We'll talk about those. But real roots are wherever it touches the x-axis. Now, these all have what's called a multiplicity of 1. This one right here would have a multiplicity of 2. So multiplicity of 1, that would be what's called a multiplicity of 2. We'll see that in a second. That's what it looks a little weird. It comes up, touches, and goes back up. All right, but real roots are when my graph touches the x-axis. Oh, getting ahead of myself. Maximum number of turns. So for these 4, go ahead and look at them. Pause the video and say how many times, what's the maximum number of turns for each of those? All right, so maximum number of turns again is the highest exponent minus 1. So for number 5, 4 minus 1 is 3. For number 6, 2 minus 1 is 1. For number 7, 3 minus 1 is 2. And for number 8, 2 minus 1 is 1. Maximum number of turns. There we go. Now we're on real zeros. Okay. How do we find real zeros? Well, we're going to use our calculator. I'm going to graph it. Hit clear, and let's type it out. So we have x to the 3rd minus 7x squared plus 16x minus 12. Hit the graph button. All right, now I see it doing something right here on the axis. I can't really tell what it's doing, so I'm going to hit zoom, and I'm going to go down to zoom in. Move my cursor over here to about in the middle of what it's doing, and hit enter. All right, now I'm going to hit zoom in one more time, and hopefully that's not going to be too much. It might have been. Yeah, so my x-axis kind of zoomed in a little more than I wanted. I want my y-axis, maybe he zoomed in even more. So this is what I'm going to do. I'm going to hit window. I'm going to make my x's bigger. So I'm going to say that one's 1. I'm going to change that to 4. But my y values, I'm going to actually make smaller. So I'm going to say that's negative 0.2 and positive 0.2, just because I want to stretch my graph. So I can see a little better what's going on. There we go. So now I can see a little bit better of what's going on by manipulating the window. I see that it touches the x-axis 2 times, okay? But it has 2 different types. I'm gonna hit the trace button. All right. Right here at this x value, which is 2. I can't get it on there exactly, but that's an x value of 2. It touches. And over here, it looks like an x value of 1. Oh, sorry, no, x value of 1. X value of 3. It touches. So it touches at 2 and 1. But there's something different going on at those. So we have x equals 2 and x equals 3. I like to put 1. So here's the 3. Here's the 1. Okay. Now, the 3 is normal. It just goes through. It's that 2 that's weird. All right. So that's what it's talking about, the multiplicity. What that means is that that 0 occurred 2 times. If it goes up, touches it, and comes back down, we have mult, which just stands for multiplicity, 2. So x equals 2, mult 2. That's a multiplicity of 2. And I really don't even need that comma there, because if I pull up their answers, they list them out like that: 3, 2 mult 2. Okay. So those are our zeros. Try number 10. Pause the video, try number 10. All right, so I typed in, I hit graph, but my window's all messed up because it's still the same window from the last one. So remember, fix my window, zoom 6. All right, so that gave me my standard window. I can see my graph, and I see it's doing something on the x-axis, but I kind of need to zoom in on that spot right there to really figure out what's going on. So first I'll just do my zoom in feature. Tap to the right once or twice, hit enter. Now let's see if that's enough. All right, still not enough to really see what's going on. So this is what I'm going to do. I'm going to think, if I could do a box like that, that was the window I saw, that would be helpful. In fact, I might even make my y values much smaller. So in reality, I'm probably going to try to do something like this. All right, and that'll force my the graph to stretch those y values out and make it a little more obvious what's going on. So that's what we're going to do. So our x value is going to be from -1 to 2, and then just make some really small y values. So window, -1 to 2, and then I'm just going to say -0.2, +0.2. There we go. Now I can see what's going on better. And then we see something else is going on weird here. We haven't seen one like this. So let's point out what this is. So first is this one. All right. That means mult 2. All right. We have seen that one, and that's at an x value of 2. So x equals 2 mult. Multiplicity of 2 is repeated twice. But now we get a third case. This one right here isn't just going straight through. It's flattening out, like it's going to come back up, but it doesn't. It goes, it flattens out, and then comes down. That means a multiplicity of 3. So at x equals 0, we have a multiplicity of 3. And you might be wondering how many multiplicities are there? Well, it goes on. I can keep going on. The problem is when I get multiplicity of 4, a multiplicity of 4 would look like this. It would come up, flatten out, and then come back down. And other than maybe it would flatten a little bit more than 2, it would be really hard to tell the difference between 2 and 4. Same thing with, say, if I do 5. A multiplicity of 5 would look like this. It'd come, it'd flatten out, and then come back down. It may be a little flatter than 3, but even multiplicities all look the same. Odd multiplicities, with the exception of 1, all pretty much look the same. 1's the easiest. A multiplicity of 1 is just going to go through normally. All right, so those are our answers for number 10. All right, pause the video and try numbers 11 and 12. All right, so for number 11, and again, I'll write them out sometimes x equals, so you would have x equals 1, x equals -2. There was no multiplicity going on, so that means they just had a multiplicity of 1. With number 12, you had a multiplicity of 3 and a multiplicity of 2, so you'd have x equals 0, multiplicity of 3, meaning it looked like either that or that. And then you had you had -1, multiplicity of 2, which means it either went up and touched the x-axis or like that, one of those two cases. So that's what we mean by our real zeros. All right, in behavior. So for in behavior, we're looking at, is it odd, even, positive, or negative? And by that we mean odd and even, highest exponent. So for instance, x to the 4th, x squared, or odd x cubed, x to the 5th. But we're only looking at the highest exponent. And then positive and negative, that's just talking about the first term. First term. Assuming it's in standard form, meaning the coefficient of the term with the highest exponent. All right, so let's look at these. What are some examples? Odd positive would be like, let's use that one. Positive 3x to the 5th. Actually, let me make sure, don't confuse that. So positive 2x to the 5th plus, it doesn't really matter. Okay, I put the 2 on there because I know the 2 is an even number, but the odd doesn't refer to the coefficient, it refers to the exponent. These 3 over here. Let's say 3x squared minus 4x plus, who cares? All right, we only care about the first term. Okay. Odd negative, well, I'm going to use exactly the same thing, but I'm just going to say negative 2x to the 5th, negative 3x squared. Okay, so that's what we mean by negative, positive, even, and odd. The first term, just the first term, determines the end behavior for the entire function. All right, now I know that looks confusing. We're going to talk about this. It's not nearly as bad as it looks. In fact, actually, it's as simple as left, right, up, and down. Okay, so I'm going to go. So if I go that way, no, we're going to go this way. So left, right. up, down. Okay. So left, right, up, and down are English words. In math, we try to be universal. So we need something that's not English, something that can be understood by anyone, any language. So we got to come up with a way of translating those into the math language. Well, left and right are both X values, right? These are both X values. And over here, up and down are both Y values, okay? So left would be X going in the left direction or in the negative direction. So we read this as LIM, which just stands for limit. We were too lazy to write out the whole word, so we just put the first three letters. Limit as X, and then that arrow is the word approaches. Approaches is too hard for us to spell. We don't know if it has one P, two P's, or three P's, so we use an arrow for the word approaches, and it goes to the left, so that's negative infinity. All right, that's how we write left in math. Right then would be the limit as X approaches positive infinity, or just infinity. By default is positive. Now, what about left or the up or down? So the up and down are what those equal. So we always are asking, we're saying, okay, this of a function, it's in color. We'll go, so we're saying the limit of f of x, the limit of f of x. So what is the function doing as you go to the left? What is it doing as you go to the right? If it's going up, we'd put positive infinity. If it was going down, we would put negative infinity, okay? So that means that my x values are here and here. My y values are what it equals. Right? So back to our chart. So before I get those, let's show an example. Odd positive is always going to look like this. Something along those lines. Again, you could squiggle more times in the middle, but it's talking about the arrows. Arrows going to the left, down, going to the right, up. Odd negative, add some more squiggles in the middle. Again, arrows, the ends, that's what it's going to be. Even, they're both the same direction. So something like that, or if I want to make it a little weirder for the negative one, there we go. Point is the arrows, okay? So let's look at odd positive. Again, each one of these is asking exactly the same thing. This is left. This is right. They're all asking, what is it doing as you go to the left? What is it doing as you go to the right? Well, let's see here. As I go to the left, is that arrow going up or down? Well, as I go to the left, it's going down. So therefore, it's negative infinity. Well, what about as I go to the right? Well, as I go to the right, it's going up. So positive infinity. Right? Same thing for the other one. If I go to the left here, the arrow is going up. So I would put positive infinity as well.
what they are. And so you can actually determine what the indications can be that call input without reacting. This is a take a picture of yours, right? Question. First question. High. That's what I mean. Same. Everything's same. Now, like, this is probably the first thing. It's definitely I'm positive. Even that is